Hey everyone, and welcome to this explainer. Let's just jump right in, shall we? Today we're looking at this amazing intersection of massive scale engineering and global sustainability. When we think about renewable energy, we usually picture those huge, majestic wind turbines spinning on a hillside or massive offshore farms catching the ocean breeze. But let's be honest, we rarely stop to think about the absolute monumental effort it takes to get those gigantic parts out there in the first place. So today we're breaking down how a highly specific structural innovation is totally reshaping how we approach renewable energy shipping. We're going to explore how wind energy logistics is getting a really smart, highly focused upgrade.
Now, to really grasp the problem here, you've got to understand the sheer scale we're dealing with. 81. We are talking about moving a single windmill blade that measures an astonishing 81 meters in length. Just take a second to process that scale. Moving objects of this colossal magnitude across the globe, well, it's not just about finding a bigger boat, right? It's a profound engineering challenge. You're dealing with highly awkward dimensions, ultra-precise weight distribution, and the aerodynamic fragility of the blade itself. Moving these things requires immense precision, deep engineering know-how, and, honestly, just an incredible amount of sheer physical space.
And that brings us to the bottleneck. For the past 4 years, there's been a strict, unyielding capacity ceiling on these specialized UHL vessels. The magic number? Stuck at exactly 45. Because of the crazy volume and complex weight distribution of these 81-meter blades, loading 45 of them was considered the absolute maximum you could safely transport on a single voyage. For 4 whole years, that was the hard ceiling. It didn't matter how much the demand for wind energy surged. If you wanted to move more blades, well, you needed more ships. And in the shipping industry, more ships means more time, massive logistical headaches, and ultimately a bottleneck in building our sustainable future.
Section 1. An innovative stacking solution. Breaking the capacity ceiling.
So enter the VO Chidambaram Port Authority, or VOCPA for short. They looked at this strict spatial limitation and essentially said, nope, 45 is no longer our finish line. They took this massive logistical headache, threw out the conventional wisdom of the last 4 years, and tackled it head-on. And the mechanical ingenuity here is actually quite elegant. It breaks down into 2 crucial steps. Step 1, they physically extended the deck of the UHL vessel by installing additional heavy-duty support beams. They literally pushed the boundaries of the ship outward to create more usable, secure real estate. Then, step 2. Rather than just laying the blades out in the traditional format, they engineered a safe way to stack these 81-meter giants all the way up to 5 tiers high. By reinforcing the base with those new beams and building upwards, they turned a super frustrating 2-dimensional layout problem into a 3-dimensional vertical storage triumph. It's brilliant.
Section 2. The efficiency leap. The results of structural innovation.
Now, these structural changes aren't just clever engineering tricks. They're absolute game changers for operational efficiency. Remember, for 4 straight years, that 45-blade mark was the absolute maximum, an immovable wall. But by adding those support beams and implementing that 5-tier stacking, VOCPA completely shattered that ceiling. They brought the new capacity all the way up to 57 windmill blades on a single UHL vessel. That is an addition of 12 enormous 81-meter blades successfully loaded per single trip. Just think about the compounding efficiency of that over the course of dozens or hundreds of voyages. That leap from 45 to 57 completely resets the math on operational logistics.
So why does this matter to the bigger picture? What's the main takeaway for us here? Well, maximizing vessel capacity like this does something incredibly important for the whole industry. It actively demonstrates a relentless commitment to pushing the boundaries of innovative cargo handling. It proves that in the logistics world, the status quo is literally meant to be challenged. By optimizing vessel space so dramatically, VOPSCA highlights a really vital lesson. We don't always need to just build more ships to transport more cargo. Sometimes, we just need smarter engineering and a willingness to completely rethink how we use the space we already have.
Which ultimately brings us to this core, overarching idea, powering smarter logistics for a sustainable future. Adding a few support beams to a ship's deck might seem like this highly technical, isolated adjustment. But when those beams allow you to safely transport 12 additional wind turbine blades on every single journey, you are directly accelerating the deployment of renewable energy worldwide. You're drastically reducing the number of trips required, which of course enhances overall operational efficiency. Bottom line, smarter logistics directly translates to a faster, much more effective green transition.
And that brings us to a final crucial question I want to leave you with today. How might other logistical frameworks be optimized for green energy?
I mean, if we can entirely rethink the deck of a UHL vessel to stack 81-meter windmill blades 5 tiers high, what other massive supply chain bottlenecks are out there just waiting for a smart structural innovation? The future of renewable energy isn't just about designing better solar panels or building taller turbines. It is absolutely about figuring out how to efficiently, safely, and smartly transport these massive components to every corner of the globe. So, I want you to think about how these exact types of space-saving innovations might just be the hidden key to unlocking a truly sustainable world. Thanks so much for joining me for this explainer, and as always, keep questioning the limits of what's possible.